Hi everyone! Today let's talk about section 1.2, Propositions. The study of propositional calculus is the study of logic involving statements that are either true or false, together with the logical operators. The statements which are either true or false are called propositions. So here are some examples and non-examples. So let's figure out which ones are propositions. Okay, first, the sky is blue. Is this a proposition? Is this true or false? So if you can tell this is true or false, then it is a proposition. So the sky is blue. Let me see. It's sunny today, so this is a true statement. So yes, this is a proposition. And for today, this is true. Okay? How about the next one? 2 plus 2 equals 5. Well, is this true or false? We know 2 plus 2 is 4. 4 is not equal to 5. So this is false because we can tell whether it's true or false. So this is a proposition and it is false. Next, Suki teaches at Indiana Tech. Is this true or false? It's true, right? So check mark, yes, this is a proposition and this is true. Please do your homework. Is this true? Yeah, kind of. It's very important to do your homework. But this is not a proposition. It's a command. Okay, so this is a command. Okay, it's very important to do your homework. Yes, please do your homework. But this is not a proposition. So let's cross it. Okay, but how about if I say Suki has done homework 1? Is this a proposition? Yes. I have done homework 1, so this is true. So this is a proposition and it is true. Okay? Have you done your homework? Okay. Next. X minus 3 equals 11. Is this a proposition? Not really, because we don't know what X is. Okay, so that's why here we cannot say whether it's true or false. So this is not a proposition. It really depends on the X values, right? So if I change the statement to 14 minus 3 equals 11, is this a proposition? Yes, and 14 minus 3 is 11, so this is true. And if I change the statement to 13 minus 3 equals 11, is this a proposition? Yes, and it is false, right? Next. Happy New Year! Oh, well, this is not a proposition, right? This is just a greeting, right? Okay. We often use letter variables to represent propositions and the symbol to represent the logical operators. So let P be the statement. The sky is blue. Let Q be the statement. It is raining. Okay. So what are the logical connectives? So the connectives, the common ones are and, or. So and, we use the symbol. Do you remember last session we talked about sets? Okay, and we talk about intersections and unions. So intersections for sets, let me put it here. So A intersect B, right? This is an intersection. It looks like the N. And for union, so this is intersection. And is like and. For union is A union B, and this is like or. You can see this is for sets. Today we're talking about propositions, right? For propositions, we can have and or, right? So for the symbol and, you remember for sets, it looks like this. So now we have a sharp angle there. Okay, so this is the symbol and for logical connectives, logical operators. Or we use, this guy looks like a V, right? And we say the and is a conjunctions. Prepositions are joined together with and. So we have P and Q. It means the sky is blue and it is raining. So the or, we call it disjunctions. Prepositions are joined with or. We have P or Q. The sky is blue or it is raining. Okay, so here are the two logical operators. So here we have another example. Preposition P is 3 minus 11 equals 8. Preposition Q, ice is cold. Consider P and Q and P or Q. Are they true or false? Okay, what is P and Q? So P and Q is 3 minus 11 equals 8 and ice is cold. Okay, is this true? Okay, so think about it. 3 minus 11, what is that? That is actually minus 8. So it's not equal to 8. So this guy is false. Ice is cold. That is true. Okay, so we have something and something. So when you see the and, this statement is only true when both of the two prepositions are true. Okay, but in this case, we have 3 minus 11 equals 8. This is false, and the other one is true. So the P and Q, the result is false. Okay, how about P or Q? P or Q means 3 minus 11 equals 8, or ice is cold. So this statement is true as long as one of the statements is true. And because ice is cold, it is true. So this statement is true. Okay, so far so good. Alright, so when are the prepositions with connectives considered true or false? Here we need the true tables. So this is true tables. We have P and Q on the left, and then we have the P and Q, or P or Q, okay? So it's whatever logical connectives between the prepositions, okay? So these are fixed. Okay, so think about it. How many possibilities are there? Remember, P and Q, we have two prepositions, and each of them can be true or false. So it's like two boxes, and each one we have two choices, true or false. So together, we multiply them, we have 4 possibilities. So that's why when you draw the table, your left-hand side, you're going to put TT, FF. So true, true, false, false. And the Q is true, false, true, false. Then it will give us all the 4 possibilities. Alright, so now let's think about it. P and Q. So this is N, right? P and Q is true only if both of them are true. So if both of them are true, we get P and Q is true. And if one of them is false, okay, or both of them are false, then the result is going to be false. So far, so good? Okay. Next, let's look at the inclusive or. So what is the inclusive or? So inclusive or means you can choose A, you can choose B, or you can choose both of them. Okay, so in this case, you realize the left-hand side is always the same when we have P and Q, two statements. Oops, sorry. I pressed the wrong button. Okay, and so P or Q is true if one of them is true. See? One of them is true or both of them are true, then this is true. And if both of them are false, P or Q is false. Okay? And this is usually the math. When we talk about or, we mean the inclusive or. So math usually means the inclusive or. However, English, when we say or, it usually means the exclusive or. So exclusive or, it means that, well, you have to pick one of them, okay? So if both of them are true, the result is actually false. If exactly one of them is true, the result is true, okay? Of course, if both of them are false, the result is false. All right. So let me put more notes here, okay? For and, if one of them, oops. So if one of them is false, then the result is false. Okay? For inclusive or, if one of them is true, then the result is true. Okay? And for the exclusive or, we need exactly one. So exactly one is true, then the result is true. Okay, so let me put result is true. Otherwise, if it's like 0 of them is true, or none, or 2 of them is true, then the result is false. I can give you an example here. It's like A is dating 2 girls. Okay, and that's not good. B and C. So the 2 girls find out that. So then A must pick B or pick C. Okay, and can pick both. Oops. So can pick both. Okay, or in the US, you can only have one wife, right, or one husband. So yeah, in the state of Indiana, yes. Okay, just an example to help you to get the feeling of that. Next, we have the negation symbol, not. All right. So P is the state proposition. The car is red. Then not P means the car is not red, right? So the car is not red. And that is the not P, okay, negation. All right, next, how do we evaluate logical propositions? We evaluate the logical operators in the order of not, and, then, or. Okay, so that is the order. We must find the not symbol first, and then evaluate that. And then next is the and. Finally, that's the or. Okay, so next. Example, evaluate, put the order on top of the symbol and figure out the value when P is true. So P is true, Q is false, and R is true. Okay, so remember the order is not, and then or. So we look at the not symbol. So here we have not P. P is true, so not P is false, right? Okay, next we look for the and, right? Here we have the symbol Q and R. So Q and R is what? So Q is false, R is true. So false and true is false. Okay, then finally we have false or false. 2/4, the result is false. So far, so good, everybody. So here you can see the the steps. The first steps we consider not P. So because P is true, not P is false. Second step, we're looking for the and symbol, right? So Q and R, because one of them, the Q is false, then Q and R is false. The third, we look at the whole thing, then we have the not P, which is false, or the Q and R is false. So false or false is false. Okay, so the answer is false. So it's very important to remember the truth table. All right, let's continue. Next, you can see here if the problem want us to evaluate the and first, then we can have a parentheses. So the parentheses tell us that we should evaluate the logical operators inside the parentheses. In this case, the first step we look at P and Q. So P is true, Q is false. P and Q, true and false is false. And then the second step, we look at not false, then this is true, right? So the answer is true. So far, so good, everybody. Let's continue. Part C. Part C, we have P and, okay, so here we should look at inside the parentheses, right? And we have a not there, so the first step, we should look at not R. So R is true, not R is false. This is the first step. Next, we want to have Q or not R. So Q is false. False or false is false. And then finally, P is true. True and false is false. Okay, so the answer is false. So far, so good, everybody. Okay, so you can draw these lines, then it can tell you the steps. Okay, next. Let's calculate the inside the parentheses. P and Q. So P and Q, that is true and false together is false. And then here, here we should calculate not Q. So not Q is true. And then next, we have the R and not Q. So R is true. True and true is true. Okay, and then this side, we have not F. Not false is true. Finally, we have true or true is true. So the answer is true. So far, so good, everybody. So remember, when you watch the videos, you can pause anytime to think through the math, or you can replay the videos, and you can also change the speed. You can make it double speed or slower. Okay. Next, so what we have done is we assume that the P is true, Q is false, and the R is true, and then we figure out the true or false for all the parts A, B, C, D. So next, we're gonna draw the truth table. Okay, so what we just did, we have let's see, P is true, Q is false, R is true. So we have false, true, false, true. Okay, so that's fine. So P is true, Q is false, R is true. So we just did this one. And then the answer is false, true, false, true. We just did that. How do we do the rest? Okay, let's do the rest. Okay, now this is in general what we do. We can draw a truth table. Okay, let me use a different color here. So remember last page, when we only have two propositions, P and Q, then there are 4 possibilities. But now we have 3 propositions, P, Q, R. Then each one, we have 2 choice, true or false, right? So all together will give us 8 possibilities. So when you draw the truth table, first, you look at the P. Well, you know, 8 divided by 2 is 4. So that's why you put 4T here and 4F there. Okay? And then next is gonna be Q. You put 2T, 2 false, 2T, 2 false there. Okay? And then the last for the R, you put TF, 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 alternating. Okay? So in this case, you will have all the possibilities. Okay, so this is the way we draw the truth table. Okay, so now let's see, how do we think? So let's denote the steps. So here first, we do not P, and then we do Q and R, and at the end we do not P or Q and R, right? So here, not P. P is true, not P is false. And then Q and R, T and T is T. Okay, so sometimes, yeah, we put this symbol, okay, and then false or true is true. So in this case, we have true. Okay, and then let's go to the next. Not P, not true is false. Q and R, because R is false, then we know and will give us false. And false or false will give us false. Okay, and next one we already calculate. And the next, not P is false. And then Q and R, false and false is false. So false or false is also false. Okay. And then continue, we have not P. P is false, not P is true. Well, we have true and something. Actually, we don't need to know what this thing is, because true or whatever is true. Okay? And this one does not matter. Similarly, all of these, all 4 of them, because the P is false, not P will be true, and then true or whatever is gonna be true. So that's why we know is true is true. So far so good, everybody? Let's continue. So next one was the order. We first calculate P and Q, and then we do not P and Q. P and Q, let's look at. Okay, so P and Q only involve the first 2 propositions. Okay, so P and Q, so true and true is true. So not true is false. And then next, still true and true. So not true is false. And you can see, because both of them are the same, this answer will be the same. And then okay, and because both of them are the same, this answer will be the same as the top of one. Okay, and these 2 are the same, these 2 are the same, so you're gonna expect the answer will be the same for these 2. Okay, here P and Q. False and true is false, but not false is true. And here is the same with that one. And then here, false and false is also false, so now false is going to be true. So then this one is the same. So far so good, everybody? Alright, next. Well, next the order is we first calculate not R, and then we calculate Q or not R, and then P and that. Okay, so not R. Not R is, so this guy, R is true, not R is false. And then we have true or false will give us true. Okay, so that will give us true. And what happened? P is true. True and true will give us true. Okay, next, Q is true, and or not R is true. Oh, so true or true is true. And then P is true, and true is also true. Okay, next we already calculate. And then Q is false, R, not false is true, so that is true. P is true, and true is true. Alright, next, do you realize because P is false and you have false and something, and false and something is gonna be false. So this guy does not matter because false and whatever is gonna be false. So sometimes think more can save our time. So you see the similarities. We realize it's false and something, and we don't need to figure out what this thing is. The answer is going to be false. It's like when you do an algebra problem and you figure out you have 0 times something. You don't care what that thing is. 0 times that number is going to be 0. Right? Okay. Next one, this one is more complicated. So let's see. We should calculate this, and then we do the not and or. Okay, P and Q. So true and true, and R and not Q. Well, R and not Q is false. So false and true is false. So this is false. And not true. So not true is false. False or false is gonna be false. Okay. Next, P and Q is the same as before. So P and Q is true and true is true. So not true or R is false. False and whatever is gonna be false. Wow, we have the same thing, right? Not true is false, or false equals false. Alright, let's continue. So P and Q, true and false is false. So not false. Oh, actually, you see, I don't care what this is because this will not false will give me true. True or whatever is gonna be true. Yeah, sometimes you realize, we don't need to figure out this guy, right? Okay, and then next, wow. So actually, for all the rest, because your P is false, and whatever Q is gonna be false. And then not false or something, not false is gonna be true, but true or something is gonna be true. So all of these is gonna be true. Because if the P is false, then in this statement, P and Q will be false. Not P and Q is gonna be true, or whatever is gonna be true. So we can figure out all of these 4. So far, so good, everybody. So I hope, now we have 3 propositions, then we have 8 possibilities. Or if we have 4 propositions, how many possibilities will be there? Yes, 16. So our table can get bigger. But usually, we'll do at most 3 propositions. So at most 8 possibilities. Okay, and yes, and when you look at the logical operators, be careful with the order, and sometimes think more can save you sometimes. So for example, true or whatever is true, false and whatever is false. Okay, so keep those in mind. And this is session 1.2. We'll continue in our next class. Bye!